Kia ora koutou katoa, and thank you, Daniel, for joining us all the way from the UK this morning, or it's evening for you.
Well, thank you very much for inviting me.
Welcome. Daniel, you are one of the co-founders and trustees, together with Susan Crumdyke, of the Global Association for Transition Engineering, known as GATE. Tell us about how this association came into being. What was the need that you saw there?
Well, when I was working at Ford Motor Company as a product engineer back in 1996, we came to the end of a big project, which was the Ford Focus. And I asked myself, what was the biggest challenge out there to which I could apply such engineering expertise as I had at that time? And I realized that the biggest challenge was sustainability, by which I mean the capacity to continue. And I could see then that although people had known about the challenges of sustainability since the 1960s and Silent Spring by Rachel Carson, the actual trends were just carrying on, and there'd been actually no change at all. So I realized that we needed a kind of engineering that would bring about that change. So I started doing that work and researching and developing tools for things like design for recycling and engineering for sustainability and so on. And then I thought, is this thing something different? And I came up with the term transition engineering in 2009. And I Googled the term and I found the other transition engineer at the time, which was Susan Crumdyke. So I sent her an email and I said, I think we're the two transition engineers in the world. So we kept in touch from then. She came over to England in 2011 and gave the first seminars here. And then in 2013, we founded GATE to bring together all the other people interested in the subject.
Wow, amazing. They say that the good ideas always float to the top, so that's what was happening on two different sides of the world that was being created. So, Daniel, what is actually different between transition engineering and sort of traditional classic engineering, which is, of course, is very focused on solving problems and challenges and overcoming constraints and so forth? What is it that makes it different, that it adds to current engineering disciplines?
Okay, well, you can see other engineering disciplines like mechanical engineering, which is all about machines, civil engineering, which is all about buildings, structures, electrical engineering, which is about electrical things. They're all about things and stuff. And transition engineering is specifically about change towards the future. So it's focused on the future. And it's the engineering that ensures that the future vision or strategy is consistent with the constraints of the future operating environment. So we focus on the future business operating environment, and many business leaders don't do that at all. They assume that the future is going to look like the recent past.
Right.
And the particular challenge we have at the moment is that historically we are at a time of inflection. So we are going on a trajectory round a corner, if you like. And this hasn't happened for many generations in engineering. And so we need a kind of engineering that allows you to go around the corner when you haven't been around the corner for a long time.
Right.
And it's that change of direction that we're delivering.
Yeah, no, that makes a lot of sense. I know from my background in product development, we're very focused on the present. What are the needs currently, and you might project a little bit of growth into the future, but you're not really thinking about the future. So that's quite a different perspective on how you're approaching things.
Exactly. And one of the key things is about challenging all of those assumptions. And you mentioned growth into the future, and even that should be challenged. And it's quite easy to work out that one of the key constraints in the future is that everything that uses energy will have to be adapted so it still does what we want it to do with 80 or maybe 90% less primary energy. So that's a key constraint.
Wow.
And of course, equivalent reductions in carbon emissions as well.
Mm-hmm. Right. And so what are some of the other, obviously that's a very key point of the way that you're approaching problem solving and all of those things, you're overlaying that on traditional projects. What are some of the other things that make it quite different in the way that you're working?
Well, in terms of all of the debate you'll hear about sustainability, there are a lot of voices out there saying why change is needed, but transition engineering tells you how to deliver that change when you've already worked out that why it has to be done. So all the voices out there like David Attenborough, Greta Thunberg, XR, the United Nations, all the climate change committees, they all know why we need to make change happen. And you can see a pattern, and those people are doing a great job, there's no doubt about that, but you can see a pattern that they're very, very eloquent about why change has to happen. And when they get to the last chapter of their book, they kind of have to propose some solutions, but you can tell they're then out of their depth. And often those solutions are not consistent and so on. Whereas engineers, that's what we do solutions. So really, it's the engineers that need to be involved in working out how to bring about change. And that's what transition engineering does. So it's a really relatively simple 7-step methodology that you can apply to many, many complex situations that enables you to work out how to make change happen. So it's not like we said before about different disciplines of engineering all are focused on particular technologies. Well, we know that a technology only solution won't deliver the results that we need. We have to have change, but that doesn't mean no technology. There'll be exciting technology, but it'll be different from what we've got at the moment.
Right. Yeah, that's great. And another thing, the online course that we've been running through Canterbury University this year in transition engineering, we've found we've had a lot of students from not just engineering, so economists, from political, even psychologists, a lot of different people very interested in this topic. So why is that? Because you don't see that with normal engineering disciplines. You're not getting a wide range of people involved or interested in this topic.
No, you're quite right. And people talk about silos and so on, and that is a problem in creating solutions. What I realized that you have this commonly accepted 3 corners of sustainability, which is ecology, economy, and society, or expressed in different ways. And all of those are different. They're professional people. So you've got ecologists, social scientists, and economists. Mm-hmm. Okay, and engineering sits somewhere in the middle. So we're none of those, but we sit somewhere in the middle. And I realized that actually we need to talk to all of those people. So starting with the natural scientists who understand ecology and the laws of physics, and engineering is about applying that learning to benefit society. But we need to talk to economists to make sure things work in terms of economics. We need to talk to social scientists to make sure that things work in terms of society. And also there's another professional group that we've started to bring in, which is creative professionals, whose role is to observe and interpret for other people things that are difficult to understand. So bringing all those people together hopefully will lead to better communication, like understanding how all the different professions use the same words to mean different things, and coming to some consensus about how we use the words, even really basic things, and then dreaming up and creating these amazing path break solutions that can be consistent with everybody's understanding. So that's why we want to include all professions at the same time, even though it's called transition engineering. And it's important that the engineering is in there, because that makes sure that it's based on data and numbers and scientific learning.
Right. So it's a very interdisciplinary type practice where you're bringing a lot of people together, and you've got, you know, the science as input, but you need to communicate with all these different groups and bring them along and provide the, I guess, the data and the evidence, and that's based on those constraints and so forth, to be able to implement these projects.
Yeah, totally. Very interdisciplinary. And also, you'll find that the actual process is very different from other engineering disciplines, where you might do a lot of work on a desk or on a computer, doing a lot of analysis and so on. One of the 7 steps in transition engineering, which is step 4, which you'll cover later on today, I'm sure, is about creating path break concepts. And to do that, that's where you need to bring all the different people together and get them working really closely together. And there are various facilitating tools that you can use to do that. And you bring all those people together, and that's where you get the amazing creative ideas that actually can crack a difficult to solve wicked problem.
Right. Tell us a little bit more about wicked problems, because that's I guess a term that comes up a lot in transition engineering, but maybe not everybody's sort of familiar with what a wicked problem is.
Okay, well, to start with, a simple problem might be an engineering simple problem might be if you're challenged with redesigning a car to deliver 5% more miles per gallon. That's a simple problem. Mm-hmm. But a wicked problem is a problem like climate change, where you've got many factors involved and many stakeholders, different stakeholder groups. You've got a lot of potential for conflict. You've got a lot of disciplines involved, so policy making, engineering, science, and all that, and no obvious clear answer. You can't say, if we do this, we will have solved the problem. It's not, it's just complex, difficult, hard to solve.
Right. So really, GATE and, you know, transition engineering, you're really calling for engineers and for other people to kind of step up and work on these extremely complex problems, but you're also giving them a way how to do that, which I guess is the key thing, that we know the problems often, but the how is the thing that's been missing. And that's what you were saying earlier, right, about it's providing that to the I guess the discipline.
That's right. And we hope that before too long this will be common practice, but right at the moment we all need to be reaching out to those people like the United Nations and David Attenborough and the media and so on, because we're still very small and a lot of people don't know that we're there, and we need to get the message out there so that people know about it.
Right. Well, I guess today's conference is a good place to start.
Definitely, and I hope it goes really well.
Yeah, well, thank you very much for sharing that with us, and I know that you'll be continuing to join us for part of the day until it gets a bit later at your end, but really exciting. I think that it's great to hear that so much work has already been done and so many things have already been thought through, and now we have courses, we have textbooks, and we have people in different parts of the world all sort of developing transition engineering and thinking about this, and we're all learning and sharing that. So it's pretty exciting and great to be involved in the how of how do we move forward and how do we solve these problems. So thank you very much, Daniel.
Well, thank you.